Today we are going to look into separation techniques, as you can see, and this is one of the basic chemistry ideas. Is mostly applied in practical chemistry. That means that this is a practical chemistry session, but I want to look into the conceptual aspect of it. And when we go over to analytical chemistry part that has to do with more of the practical aspect of chemistry, we're going to demonstrate some of these we are going to learn here. And I can still tell you what you can do at home to demonstrate each of these things, so that it will be much closer to you than being abstract. What we actually mean by the word separation techniques. There are so many activities we employ when we want to separate mixtures, and we do this by taking advantage or consideration of the physical properties of the components of the mixture in order to separate them. All this thing is what we mean by separation techniques. This means that for us to separate a mixture, we really need to know the components of the mixtures, as I wrote here, components of the mixture, and we also need to know the physical properties of the components of the mixtures. So when we know these two things, we can actually separate mixtures by physical means. We are going to have the concept of separation techniques under the three formats: separation of solid from solids, separation of solids from fluids, and separation of fluid from fluids. Let us start with separation of solid from solids. We have three major separation techniques we are going to employ in separating solid from solids. And note that each of these separation techniques are based on the physical properties of these mixtures components. Hope you get that. We have three major: sieving, magnetic separation, and sublimation. Sometimes some people can call this demagnetization. Hope you get that. Okay, we need to look into them one after the other. Let's start with sieving. This is a separation of solid from solids of different sizes by using a mesh. Here, the size of the solid is what is needed. So we have different sizes of the mesh, and the solid passes through the mesh, and the mesh looks like this. This is just a sample of a sieving mesh, and it depends on the size. You normally see this at home. Hope you get that. Okay, these can actually be employed in separation of fine sand from different sand particle sizes. We can also employ that in separation of gari from its chaff using mesh. We can also make use of this in making flours and powders. They are really important. The gari industry and flour and powders industry, even sand industry, make use of this sieving. That means that this is important both locally and industrially. I hope you get that. Let us look at magnetic separation. This process tries to separate magnetic solids from another which does not possess magnetic property. The physical properties that are being applied here is the attraction to magnetic field. So each solid that is attracted to magnetic field will be attracted or be separated away from a group of other solid that does not have attraction towards magnetic field. We can actually apply this in separation of iron, steel from mixture of iron and sulfur, or steel and sand. We can also use it to pick steam pins, iron pickers in extraction of iron. This is a separation technique that tends to separate a solid that sublimes from a group of solids that does not sublime during heating. And we have some half full of this solid that sublimes. Example like iron 3 chloride, ammonium chloride, aluminium chloride, iodine, benzoic acid, camphor, even naphthalene. These are those solids that when heated, they change from solid to gases directly without passing through liquid. That is, camphor, naphthalene, iodine, they do all this, including the iron trichloride, ammonium chloride, and aluminum chloride. Even the benzoic acid, that is what they do. When you heat them, they will form gases. Now, when we have them mixed together with something like sodium chloride that does not do that, we can actually separate them just by heating them, since we know that they are going to separate up and form by gas and form solid up. That is what happened, as you can see in this diagram. This is very, very important you know this, because the A is the inverted funnel. That is this thing you are seeing is the inverted funnel. B is the sublime solid. This sublime solid might be the iron trichloride that was heated and is sublime. It might be this, it might be this, it might be any of them. The mixture has to do with anything like this against this against this, or this against this. That is what they mean by the mixture. And this triple stand actually supposed to be a 3-line, but I'm using 2 to represent it. And the Bunsen burner, this represents a Bunsen burner, and wire gauze to help make sure that this glass is not heated directly. Okay, so we will be going towards the separation of solids from fluids. We have decantation, filtration, flotation, centrifugal, precipitation, evaporation, crystallization, recrystallization, and we still have many more, but we are only going to look into these 8 in this video. You can use Google to get more of separation of solid from fluids techniques. Let's start with decantation. This is a separation technique which separates insoluble solids by carefully pouring off the liquid over a wedge. The idea here is that the solid is allowed to settle down, and the person will pour it through this and holding a glass rod to separate it. And to be frank with you, it is not for accuracy. If you're looking for accuracy, this is not a right method to use. And example is mostly used by our parents when in preparation of beans. Some people use that locally. Therefore, it's not that important in separation technique, but we still make use of it in separating technique. It is a quicker way of separating insoluble solids. This method of separation is done by using a filter paper and a funnel. This is a sample of a filter paper. What we do is that we fold it, as you can see here. We fold it again. This is 180 degree. We fold it again to get 90 degrees, as you can see. So we can open here. I hope you get that. Insert it inside a funnel. This is a funnel. Okay, then we will pour in the mixture that has a something like precipitated salts, and the other one that can dissolve. Then we want to separate the filtrate from the residue. The precipitated is going to stay here, and those ones that stay here, we call it the residue. The one that passed through this is what we call the filtrate. Note, I use this, not this. I use this place, and I do not open this. I hope you get that. Therefore, the A is the mixture, the B is the funnel, the C represents the filter paper, the D is a rotor stand with a clamp that is holding this. The E represents the filtrate. Then that means that what is inside here is what we call the residue, whereas this is the filtrate. A simple example of this is separation from a mixture of sodium chloride and silver chloride in water. And when we have this is actually insoluble in water, but sodium chloride is soluble in water. Therefore, sodium chloride will dissolve in water, whereas eddy clean, that is silver chloride, won't. And we use filter paper as demonstrated here. Therefore, the one that will remain here will be the silver chloride as the residue, whereas the one that passes here, which is this E, like something that look like this E, is what we call the filtrate, which is the sodium chloride. And we make good use of this in nickel, JUPEB, WAEC, NECO practical exams. At least in every 5 years, at least once we make use of it. Therefore, it is going to be applied in your school. And also going to demonstrate it when I'm discussing on my analytical chemistry topics, where I'm also going to demonstrate each of these separation techniques that is available, and it is easier to demonstrate, that does not have too much equipment that I might not have available with me. Therefore, I want you to look into this and get this idea. Remember that I said something about filtrate and I said something about the residue. The residue is the one that remains here, whereas the filtrate is the one that passes through the filter paper. Remember, I did not perforate anything here. We are going to demonstrate this in my analytical chemistry, where you are going to learn some other concepts and the demonstrations in analytical chemistry. And we are going to continue with flotation, centrifugal, and precipitation. This method is mostly used in ion extraction and chaff removal. Even though in the academical part it is not mostly employed, it is a separation of suspended solid made to flow on a liquid substance and carefully remove the solid suspension. You can just use your hand and clear it. Some people use some other material to clear it. I hope you get that. This is being wound over and over. After some time, the particle will settle. It is a separation of solid which are not easily deposited in a liquid. Therefore, we do this by swelling the mixture in a centrifugal machine. It is mostly applied in separation of particles that are found inside blood, and this is done in the hospital. Okay, let's go for precipitation. This is a process of separating or recovering a solid which is soluble in a particular solvent by using a substance that it is not soluble in. If, for instance, iron 2 tetraoxosulfate 6 is dissolved inside water, and we want to recover that iron 2 tetraoxosulfate 6 without even heating it, we can just add ethanol to it. It will precipitate iron 2 tetraoxosulfate 6. This is because iron 2 tetraoxosulfate 6 is not soluble in ethanol. Ethanol is soluble in water. Therefore, ethanol will precipitate iron 2 tetraoxosulfate 6. These separate solids which does not decompose upon heating to dryness, and they are actually soluble solid, that is, they can dissolve in a particular liquid. Let's say water. They are soluble in water. Now, if you want to recover them, we heat them to dryness, and when this is being done, what happens is that the solid are recovered back to what it is. If I apply this in recovering of sodium chloride from a salt solution, and we can also get that applied in those people that used to manufacture salt or used to recover salt for us before they sell it off for us. That means that if you go to those people that live close to the sea, what they do is that they get the water, expose it to the sun, and the sun help to evaporate the water, and the remaining will be the salt. And I need you to know that this is representing A, the salt solution, the B represents a paper wedge to allow the steam here to go off so that it will not become a problem to this. And we have a water bar. We are heating this so that we are not heating this directly. This is, even here we have a wire gauze present here, and the heat is actually coming from a Bunsen burner. Crystallization is a separation technique by which a soluble solid which decomposes upon heating or upon strong heating is recovered by first heating the mixture to a saturated solution, and the crystals are allowed to form as the mixture cools. See what happens here. There are some compounds or salts that when you heat them, they will decompose. What we mean by decompose is something like splitting into different substances. Substance like copper 2 tetraosulfate 6 pentahydrate, that is CuSO4.5H2O, copper 2 triosonitrate 5 trihydrate, CuNO3, this is NO3 in a bracket, then 2. Okay, you get that? Okay, iron 2 tetraosulfate 6 heptahydrate. These are such that if we heat this strongly, it is highly possible that they will decompose. Therefore, the best way to do this is to heat them to reach their saturated solution. What we mean by saturated solution is their solution in which they have the maximum number of the solute, which is this salt, that the solution can contain. So we have to know that these are salts that hydrolyzes. It can be employed in sugar and drug production, because here we are actually looking at the purity of the substance. Therefore, using this method can actually help us in that. So let's look at recrystallization. Recrystallization is a method that is being employed when we want to separate two soluble salts by considering the degree of solubility at a particular temperature. There are some salts that when the temperature increases, their solubility increases. When the temperature decreases, their solubility decreases. Therefore, we make use of this idea in separating the salts by either increasing the temperature or reducing the temperature. You actually understand this thing better when we go on to SS2 classes, when we are going to look into solubility. That is when you're going to understand, where we're going to introduce what we mean by solubility curve. Okay, we'll be going for separation of fluid from fluids. We have four major we're going to look into: separating funnel, distillation, fractional distillation, and chromatography. But I would like us to start from separating funnel. This method make use of a technique. This is a separating funnel. This is layer A, that is a liquid that is lesser in density compared to this. Okay, this one is denser than this. Okay, this is separating funnel, and since they are not miscible, the denser one will come out first, then the other one follows. Okay, we can use it in separating oil from water, even kerosene from water. The only problem I have with this method is that it is possible that the order of this may transfer to this and the order of this may transfer to this. That means that when we are even getting this layer B, the order of layer A might still be perceived here and the order of B might still be perceived here. That is the only problem I found out in this separating funnel. Distillation is a process or a separation technique that is used to separate two miscible liquid, but these ones, they have a wide range of boiling point, like this 20 degrees Celsius and above. And A is for water outlet, this is water inlet, this is a water type. And when this is being heated, what happens here is that the liquid change to gases and being collected through this leg B condenser. Hope you get that. Therefore, let me write out this value down for you here. Here I'm assuming that it is an impure water that we want to distill. Therefore, I label this in that idea. It is used in the industry, in the breweries. WAEC NECO to ask this question: which of the following separation techniques are being used in the breweries? Okay, this is the one. And let me tell you, we don't have an industry that produces distilled water for the town. That is, the town water is not a distilled water, because this distilled water requires energy. Therefore, we don't use distillation in supplying town water, but this distilled water is only used for chemists or industries. Therefore, we have industry that deals with production of distilled water. We have other way of producing distilled water. Your air condition, the pipe, the water that comes from the air condition is a distilled water. Therefore, some people use pipe to connect it and save the water. Some people still pour the water out. But for a chemist, you can actually save that for your teacher in chemistry and give it to your teacher so that they can keep on using it in doing your practical chemistry. Let's look for fractional distillation, another form of this distillation. In fractional distillation, there is just an addition of what we call fractionating column. This. Compare this with this. It does not have a fractionating column, but this one has a fractionating column. The function of this fractionating column is to permit only the fraction of the mixture that has reached a certain required boiling point, that is the temperature. It is mostly employed in the petroleum industries. There are about 2 to 3 differences between fractional distillation and normal distillation. In distillation, we use wide boiling point consideration, absence of fractionating column, mostly separates two miscible liquid, and we can apply it in brewery. But when we go to fractional distillation, you make use of whether it is wide boiling point or closed boiling point. There must be a presence of fractionating column, and it can separate more than two miscible liquids, and we can apply this in petroleum fraction separation. If we cannot make use of distillation in petroleum fraction separation, but we can actually make use of this fractional distillation even in the brewery if we want to do that. I believe that you can be able to label this just as if you carry whatever I have said here before. Just the only difference here is that this one have a fractionating column. That is just the only thing I need you to put over here. The remaining things, that is all these are just the same, just removing the. I just want you to know that everything here is here. It's just that the only difference here is that this place has a fractionating column. Do you get that? Okay, therefore if I introduce this, it's going to be F. We are going to put the F here to be fractionating column. Hope you get that. Therefore we can actually go for chromatography. This method focuses majorly on separation of colors, and this is done by considering the relative movement of solutes that are found in the mixture. For instance, this black, it is possible that the mixture of the black are green, red and blue. Now that is what make up black. Assumption, please, let's take it. I'm not an art student. It's assumption that red, blue and green make up black. Now these three substances, they have their own way of moving along with the solvent. Let's say that the solvent here is kerosene. When we insert this filter paper here in a kerosene, see, we are not letting the kerosene to touch the dotted point. This ink, we will see that it's going to move. This means that the blue color dissolve very faster in the kerosene and also move faster to it, because when you leave this in like this, the kerosene will start to climb up to this point. Therefore we will separate the colors into this. That means that 1, 2, 3 are 3 separate colors, where here represent the solvent, where these dots represent the mixture itself. I hope you get me that. Represent the mixture is a point marked, and this represents a filter paper, and it's mostly closed in you can use a beaker for it. It might be better if we use beaker for it, and we mostly apply this in. See, there are so many other chromatography, but in this class we are not going to look much on them. We have something like paper chromatography, column chromatography, thin layer chromatography, gas chromatography, ion exchange chromatography. Please, for this video and for our level of understanding this junior secondary and senior secondary school or beginners in chemistry, the basic idea in chemistry, we are not much interested in it. Therefore, in question, they normally ask you something like paint, ink, pigment, color, paste. Whenever you see something that look like that, that means that they are actually asking you of chromatography. Do you get that? Now let's look at criteria for purity of substances. These three things are criteria for us to say that this is a pure substance. And the next thing for you to these three things are criteria for us to know that this substance is pure. One, it must have a sharp melting and boiling point. Okay, if it is solid, it must have a sharp melting point. If it is liquid, it must have a sharp boiling point. Hope you get that. Refractive index is actually mostly for transparent substances. We use the transparent to know if the refractive index is not equal to that which is being recorded in a table under a certain condition, it is wrong. A colored pure substance, if you check in the chromatography, remember we just discussed chromatography last. If you check in the chromatography and the color is not exactly giving us a single spot, then we know that this is not a pure substance. Determination of melting and boiling point. What I just want you to know that there are just about 5 things we need to do in this. We have one, set up a boiling bath for heating indirectly. Insert the thermometer to continually check the temperature change. Put the substance you want to check is melting or boiling point in a container, and then in the water bath. You know the water bath is already on fire. Okay, allow the substance to either melt or boil. Then at the point where this substance melt or start to boil, mark the temperature. Thank you very much for clicking on this video. Don't forget to click likes, notification bell for subsequent videos on that look like this, and subscribe if you have not subscribed. It is very, very important. It's going to help me for me to have a better chance in YouTube platform. Don't forget to spread the message to people around you.